excuse me, I'm in a similar kind of boat in that I'm just still trying to learn these functional concepts and get them right. But what I've kind of done over the years is rebuilt this particular piece of software many times in many different languages. And the reason is because I find that when I'm looking at a new programming language, they will often represent their kind of better side and perhaps hide the not so good stuff. So I like to have a go with technologies and actually build something somewhat real with it, rather than just the hello world or the particular use case that technology is really sort of trying to sort of address. So what I'm building at the moment is a trading app for cryptocurrency. So automatically trading cryptocurrency in Elixir and Phoenix. So what I thought I'd just talk about right now is, kind of the beginning part of that development process, which is, the ingestion of the data. So a little bit about me. So by day, I'm the principal engineer at TSA Group in our innovation lab. We build contact center solutions. Sadly, we don't use any Elixir, although I'm probably in a position where I could say, thou shalt write everything in Elixir, but probably at this stage, I'm not quite going to do that. Our stack is all Go, React, and a little bit of Python, and everything's in AWS, and we are hiring. But by night, I guess you could say I'm having a bit of a tech crisis, personal tech crisis, because I'm a little bit disenchanted with a lot of the programming languages that I've worked with, and possibly paradigms, and that's one of the reasons why I've kind of been looking over the fence at what functional developers have been doing, and quite interested with that approach and keen to sort of learn and understand that a bit more. But I'm definitely looking for tooling, frameworks to a certain extent, and programming languages, ecosystems, if you will, that have good productivity and great developer experience. I don't tend to do a lot of code katas or things like what Rihanna's gone through there. My style of learning is to sort of jump straight into real world stuff and sort of go for the learn on demand approach. Sometimes that can result in gaps in knowledge, but for me to understand things, I find I need that real world application. So what I'm building here is, as I said, a platform to automatically trade crypto based on technical analysis. So it's a web app with many background processes, and that's one of the reasons why Elixir and the Erlang virtual machine are potentially good candidates, because of OTP. I'm not a huge fan of microservice architectures, because you kind of go from having one problem into as many problems as you've got services. So having everything under the one application, or I think as they refer to it as like an umbrella app, appeals to me in terms of simplicity and approachability. So I'm consuming data from a website called Binance, and I'm not sure how many people in the group, actually trade crypto, hold crypto, or hodl, as Paul said. Or is crypto new to everyone? I'm going to say it's new to everyone. So I might show you guys a little bit around Binance, where the data comes from in a moment. But basically they provide both API and WebSocket access for free to the kind of data that you would need to do your own trading or data analysis and technical analysis on those financial markets. So that's the next step, is once you've consumed it, is to transform it and apply the technical analysis indicators. And in my case, I've gone for the option of storing in Erlang term storage, so ETS tables, and then, to try to rely on Phoenix's pub sub mechanism so that it can be consumed in a live view and we can see live updates in the UI. And I've got some of that stuff working now, which I'll show you in a moment. And what's sort of next on my roadmap is to then also do the analysis of that data that I've got stored in ETS tables with some algorithms, and then do the order management. So my algorithm might decide, yeah, it's time to buy, initiate that order on the exchange, hopefully make a profit, then close the order off and retire. So the data itself comes in two forms of data that I'm dealing with at the moment. One is price ticks, which is just simply a particular symbol, and you could think of this as, apples and oranges trading, or AUD to BHP shares. you know, that's really kind of arbitrary from a development point of view, what the symbols actually are. And so this is an individual event that you would have, this frame would be emitted on the WebSocket when there's a change in price, and you would just get a new series of data here. But you can also get this historically from an API as well. The K-line data, which is what is used to drive a candlestick. So I might just actually quickly show you what a candlestick looks like. So this is the Binance website right here. And you can see these, might zoom that up a little bit. You can see these like little markers here. So you've got your green and red ones. So they basically have a tail on the bottom, which is the low price for that time frame. The tail at the top, which is the high price. If it's green, then that means the bottom of the candle was the open price, and the close of the candle was this price up here. So one candlestick represents that particular period. In this case, it's a 5-minute period. So in that 5 minutes, that was the low, that was the high. It opened here and it closed here, and then we're on to the next candle. So that's where this data here represents that, the open time, and so on. And you receive it, oddly, it's in JSON format, but it's an array of arrays. So each frame will just come in as a single array with each element. So you just have to kind of positionally grab the pieces out and work with them. So that's what kind of made me feel like, well, what I really want to do here is get that into a struct so that throughout my code, I can reference it using its name, not its position, because of course, that's a sharp edge, right? You're just going to get that wrong. So taking those price ticks in, there's a struct representation of those with some default values in case they're not present. And then I've got, oops, don't use the wheelie bar on your mouse. And then we've got a function in here which will take in the raw data and generate a price struct and return it. So if you've done any object-oriented programming, I guess that's the equivalent of a constructor, so that you can actually represent that price tick as a completed struct with a bit more meaning. Same thing for the candlestick, only it's a lot bigger. You will notice though, compared to the previous slide, so we've only got, you know, a few elements in here, but in this struct, I've actually got a large number of additional members in the struct. And their purpose is so that I can, when I'm reading data, I can actually apply the technical analysis indicators and update the struct and have an updated copy of the struct that includes what these values are at that moment in time. And that's to simplify any algorithmic analysis I'm doing on the data to be able to determine if it's, you know, a particular point in time where I think it might be a profitable trade to enter, but also so that this can be represented in a chart with all the technical analysis indicators visible on the chart. And I'll show you an example of that. I haven't got it finished, but it's sort of nearly there, and you can kind of see how that data actually comes out on a web view. So applying the technical indicators, I actually started off saying to myself, I've got no idea how I'm going to process this data, because of course, being newish to Elixir and the functional paradigm, I already knew that I was going to be walking into some challenges around recursion and having to get that in my head. But what I thought I'd do is, especially with a pipeline operator, which I'm a big fan of, it shows up as a triangle here because I have ligatures enabled in my editor. I am a big fan of that readability. It's very kind of clear. Here I'm pulling out the various prices that interest me out of each of those structs that you saw before. And basically taking that data and just filtering it through and getting the result back and filtering it through again and again and again, and applying each new technical analysis indicator. So in this case, calculating the simple moving averages, the exponential moving averages, relative strength indicator, average true range. And those are all sort of fairly typical technical analysis indicators that are sort of fairly well known in terms of their formulas that you would find on the net. So supervision. So one of the challenges that I kind of had to understand is people talk about your supervision strategy. And so I wanted to actually have a think about what my supervision strategy was going to be. A gen server, which is an Erlang process that's running on the VM, is responsible for managing the ETS table, and I've got another one that's responsible for receiving data from the WebSocket. So it gets into a situation where I'm hoping to have a scenario that I've got some form of resilience and robustness in the code. So that means moving away from the code and actually thinking about what the supervision strategy actually is going to be. So I'll bring up, and the best way I could think of to do that was to just simply get into, where am I? Not there, over here. Just to get into some sort of a drawing tool, in this case Google Slides, and just kind of try to visualize what the supervision strategy needs to be. So a Phoenix application, as it's sort of known, will start up whatever supervisors you like, and I'll show you that code in a moment. But then from there, it's up to me to create my own supervisors and gen servers to handle the data and the data processing. And something I've not yet implemented yet, and this is a peculiarity with the data feed that I'm dealing with, is if a gen server goes down, as we know, and this is the reason why we do this, the supervisor will bring it back up again. However, the particular WebSocket feed I'm dealing with will automatically disconnect you after 12 hours and you have to reconnect. So what I wanted to do here was to implement, and I've already done this implementation in Go, and I wanted to do this now in Elixir, was have the ability to start up a secondary gen server that's performing the same work as the primary gen server, then terminate the primary gen server so that there's no loss in time. When I'm disconnected from the upstream WebSocket, I could just let the supervisor restart the gen server and reconnect, but that would mean missing maybe a couple of seconds worth of data, maybe a little bit more depending on how long that socket handshake takes to initialize. So that's something that I'm still working on, is this kind of concept of like a blue-green connection to the upstream WebSocket. But that's roughly the sort of supervision strategy that I've dreamed up, because that's something that I've not found to be, and it's a hard one, I think, from a learning point of view. There's not a lot of guidance on the internet because it seems to be very domain specific around what you're trying to achieve. It's not obvious necessarily for your particular problem what the appropriate supervision strategy might be. So as I said, so we start the main supervisor, start the gen servers for the caches, that's where the ETS tables live, and then the supervisor starts the WebSocket listeners, and I can show you a little bit of that in VS Code. So there's the application EX that you would expect to find in any Phoenix application. And there's my main supervisor that's being started up. So if we take a look at that, I've got a cache for trading pairs, a cache for prices, and then a supervisor for the K line, the candlestick data, and price data ticker. So that's where the data actually comes in from the socket and puts it into the ETS tables. So if we look at the supervisor for the K line, then that's bringing up the K-line cache and the K-line data ticker. So you've kind of got that tree effect where things are kind of isolated. So the K-line data or the candlestick data is all sort of handled under one branch of the tree. And if that all breaks, we kind of get a restart on all of those things thanks to the supervision. The ETS table stuff over here is quite interesting when it comes to the K-line data, because the Erlang I don't know, mantra, if that's what it is, you know, just let it crash, is an interesting concept to me, in that if my cache goes down, then that means my ETS table will be emptied because that memory space is freed up. So then when the supervisor starts back up again, that's great, and I can start receiving data from the WebSocket to fill it back up again. However, I need at least 200 records. So I would have to wait. That cache wouldn't be useful for me until I've received 200 records. So what I actually have here is a situation where when the gen server starts, I actually load up directly from the API. Remember where this code is. Build the ETS table. One of these functions here is the one that actually goes to the API, grabs 200 records from the API, populates those into the ETS table, and then from now on I can continue to update the ETS table from the WebSocket. So if it does crash, it would be a fairly quick process before that ETS table data is actually useful for me again. So I guess to summarize that, it's WebSocket frame, transform the data and apply the technical analysis, and then pop it into the ETS cable, ETS cache, and then in my case, do a pub in Phoenix pub sub, so that any views that are running can get access to it. So the next thing for me is to convert, and it's an interesting term that I've heard in some recent Elixir podcasts where they're talking about dead views in Phoenix, as in a view that's not a live view. So it's a dead view if it's not a live view, which is, I guess, somewhat accurate. So convert some of the existing dead views that I've got into live views. And so what I might do is actually just show you where I'm up to in terms of the code. Let me start the Phoenix server. So this is where I'm up to so far with the app. So this is basically a listing of the trading pairs that I'm currently watching. And so this data here is the data that's actually being received from the WebSocket, going into the ETS table after transformation, and then being reflected in a live view, or at least a live component for just what you see in this column. The rest of the page is just a standard Phoenix view coming out of a standard controller. But then I'm just calling in a smaller component, which is subscribing to the data that's published. So these are the different trading pairs, and there's their current price. And I just keep an in-memory track in the ETS cache what the previous price was. So as a new piece of data comes through, this will update and actually have, it'll either change to red or green, depending on what the previous one, there you go, that one just went red. So the price just went down a tiny bit. So it's moving around there. To go deeper into it, and this is the piece of work I'm working on now with the candlestick data. This is a candlestick representation of what's stored in the ETS table. So this is a charting library called Plotly, and I've got those technical analysis indicators. In these cases, these are simple moving averages that you can see that are laid out across the candlestick chart. So the next step for me is to basically make this a live view, so that as a new frame comes in on the WebSocket of a candlestick record, that I can update and keep this live. And then from there, because you might ask, well, you know, why bother building a chart when in actual fact there's awesome software out there that you can get access for free that gives you all of this stuff. The real reason for actually doing this is so that when my algorithm determines that there's an entry signal, that I can actually mark that on the chart, and I can start to see where trade entries occur and where exits occur. And from there, you can start to think about how you might want to adjust your algorithms for entry and exit, because you can visualize what's actually going on. So I'm also doing a bit of back testing with some algorithms using my hammer, which I've written a lot of over the years, is Perl, which makes it very easy to just, for me, very quickly process data and determine which algorithm is going to be the most suitable one. And once I figure that out, then I'd like to make a gen server of that to execute that algorithm each time a new frame comes in from the WebSocket, so that I can decide every update of data is now a good time to buy, is now a good time to buy, and carry on. And then from there, the final piece, the order management, including trailing stop loss and profit targets. So once you enter a trade, an optimal way to kind of manage that trade moving forward is to just keep a stop loss order just under the current price. So as the price goes up, fingers crossed that it does, you have a stop loss just below it, so that if the price then turns around and reverses against you, you get stopped out, as they say. I don't know if that was 7 minutes or not. I didn't even time it.
Cool, awesome. Thanks, Cam.
Any questions?
I have a question. Can you go back to the part where you're talking about you were worried about your you were talking about supervision strategy, and if the process that owned your ets table crashed, you'd lose the data in the ets table.
Yep.
Is the process that owns the ets table the same one with all the logic doing the processing that might trigger a crash?
No, it's not. It's as dumb as I could get it. It's just simply, here's some data, put it into ets. Yep. And then has also functions, going to say methods, functions to retrieve it back out again. So I've tried to keep that to a minimum, so that gen server that interacts with ets is just pretty bare bones. But you know, and maybe it's just because of my experience with Elixir, I have managed to crash it on a number of occasions.
Fair enough. I was going to say, I mean, yeah, I would have used a similar kind of strategy. Just have a really dumb process that just does the essentially the CRUD operations on the ets table, but with a nice pattern match to stop you getting garbage in, but without crashing it if you send something that doesn't necessarily make sense. And then you wouldn't lose any data if it crashed, and then you could keep the logic in another process that talks to it. If the stateless process crashes, it doesn't really matter.
Yeah, exactly.
But yeah, that's cool. No, thank you. It's a very good talk.
Thanks.
Developer ecosystem so far. It's a non-trivial project. You've obviously done a lot of different things.
Yeah, well, as I said, I've written this in a number of different languages. I think maybe 6 or 7 years ago, I wrote it in Perl. Then I rewrote it in Python. I think I had a crack at it in Ruby there at one point and decided very early that was a bad idea. But it's particularly interesting, I think, Elixir, like that OTP aspect, like just having a single application with all the processes doing what they need to do in the background, and at the same time having the visualization. With all of the other programming languages I've worked with so far, it's always been a case of more of a distributed architecture where there's an engine doing data processing, an engine doing visualization like a web app or something like that. Now you've got to figure out how they're going to talk to each other and all of those challenges. It's really nice to be able to go, well, here's a Phoenix web app, and it's not a bad developer experience anyway, right? Like Phoenix is actually quite a joy to build web apps in. But then to actually have all that background data processing going on just simply as gen servers is actually quite enjoyable and makes life a lot easier. You know, single repository to deploy that. I mean, I could throw that on Gig Elixir and just leave it go. Whereas if I had my previous iteration of this software, which I got to the point where it was fully operational, that was written in Go, that had 6 microservices that I had running in Fargate containers in AWS, and all kinds of headaches around how do I communicate with them. And I was using a message broker and decided RPC might be an idea. Just, you know, like that really opens up a whole can of worms around how now all of these components in your architecture are going to speak to each other. Whereas as anyone who's, I guess, done any concurrency in Erlang or Elixir knows, the actor model is actually quite a joy to work in.
I will second that. It's very nice, especially, so I'd spent a lot of time coming from like a Ruby and a Java background before I picked up Elixir. And a typical Ruby Rails setup, if you want to do background job processing, you tend to have a Redis server and then use something like Sidekick, which would spin up separate Ruby processes to handle all your background jobs. And there's a lot of ops and infrastructure involved.
Which means a lot of things that can go wrong, right?
Yeah, and it's just so nice when you get a language and environment that just does everything in the box and does concurrency really well, resilience and fault tolerance really well, and you can get close to a production environment running on a local machine without spinning up Docker containers for all your dependencies and a ton of swizzle that you just don't need. It's just a very nice experience.
Well, and what actually led me to Elixir was when I implemented this in Go, I had all of the state and all of that essentially ephemeral data being stored in a time series database. I think I mentioned that in our last meetup. I used Timescale DB. And that just really increased the overhead, and I had a very busy database, and I thought, oh, this actually really should be stored in memory, which you could certainly achieve in Go. That wouldn't be a problem, but you've now got a lot of thinking to do and a lot of boilerplate and a lot of engineering to manage that in memory and mutexes around, You know, am I going to have a problem in concurrency and start overriding stuff, getting race conditions and that sort of jazz? Whereas working with ETS tables has just really released me from a lot of those headaches. And I guess this, for me personally, is when the concept of immutability really made sense, because if you can't change data in a concurrent situation, you can't override it incorrectly. So you just sort of, that's just a whole class of problems that just no longer exist.
Hey mate, nice presentation, and I think you're onto a serious project that has some opportunities. I was wondering, what strategy do you use to test the gen servers?
Yeah, so that's actually something that I'm trying to wrestle with at the moment. From what I've seen and from what I've read, the ability to test concurrency in Elixir is probably better than a lot of other concurrent languages. Definitely Go as well, but I've not yet been able to implement anything and actually try that stuff out. I've been sort of feeling my way in terms of how this architecture should work, that supervision strategy, because as I said, I found it difficult because I'm like, well, I know what I want to achieve, but there's obviously a lot of ways that I could go about that implementation. So I don't tend to go for the test first model too often. I tend to like to get my software somewhere to a point where I think it resembles something like it's going to look like in the long term, and then go back and maybe start applying some tests, because I've been a slave to test suites in my career quite a lot. Like now you've got 2 code bases that you're working on, not just one, right? So, but I am keen to understand. One of the big challenges I've found here is that working with all of these processes and using the observer that gives me visibility of the processes is helpful, but still very challenging, and in any concurrent setting to know where you currently are in your state. So I would definitely be happy to hear about any recommendations anyone's got around testing the concurrency regarding documentation, examples, mediums, YouTubes, whatever you like, because it's difficult to conceptualize concurrency in your own mind. Like, where is my application and all of my processes? So I would definitely, at this point, now is probably the right time to do it. Like to have some tests in there to test those gen servers, and that what's in the ETS tables is what I think is in there.
Thanks. Personally, what I've been doing is just testing the handle info, handle cast functions, like testing the very specific implementations and not the whole orchestration of things. And then it's a bit struggling when you have code that depends on one of these gen servers, because most of the tests that they would run in parallel, but then you have one gen server, like a single actor. And if everyone is sending messages to it, it could just mess around a bit.
Yeah, well, I guess part of the challenge is to figure out, for me anyway, how to mock or seed the ETS tables and then run the necessary tests that work with them. So yeah,
usually it's a lot of mocking, but once you start mocking a few gen servers, things to me seem to escalate very quickly. Yeah, thanks.
No worries.
Well, any more questions for Cam?
Yeah, Cam. Is there a particular reason you've chosen Plotly, and do you know how hard it's going to be to sort of make that turn that dead view into a live view? Because that's interacting with JavaScript type libraries or plotting libraries in live view is a something I have a bit of interest in playing with in the near future. So
yeah. Look, I mean, good question. I mean, basically, what I found was, in my previous implementation that I did in Go, and I had a front end written in Angular, and Plotly just sort of seemed to be one of the charting libraries that was good at supporting candlestick charts that you have multiple charts stacked together. So Plotly is very good in that respect.
Yeah.
And then I found actually an Elixir library that wraps Plotly. And actually the implementation here is very easy. So in fact, I could probably show you that if you want to have a quick look. Shall I show you guys how that charting stuff works?
Yeah, go on.
Go on. All right, let's do it. So I've not been in this code base for like 2 weeks because work has been hell, but we'll find it. So there's a views. C-Trade web, of course, under the web page. Should be that one. No. Oh yeah, it is. There it is. So you've just simply got the Plotly plot going on, and I've passed in some chart data and some chart layout as 2 different members that go in. So actually calling that into the page is extremely easy. The view itself, and at the moment, this is probably not highly factored at all, but
Trading pair, is it?
yeah, trading pairs, that's right. Yep. I know it'll be in the controller, beg your pardon. At the moment, that's in the controller. Yeah, here we go. So this is at the moment where I've just gotten to, and I've just dumped most of this stuff in here. So basically we've got the show controller, and at the moment, like as I haven't figured out what I'm going to do about configuration for the chart, I'm just setting some variables up. And what you're seeing here is just literally an Elixir map representation of what the JSON would look like that you would pass to Plotly anyway.
Right.
So there's nothing particularly unusual or abnormal about the implementation. So if you were doing this in just a straight up front end app like React or Angular, you would just literally be building the JSON and passing it into the chart that way. Now, the beauty of this is that when I convert this into a live view, if the data, when we actually render, we're in the assigns here, so we're setting this stuff up for the template to actually make use of, if that data actually modifies, and we do this in a live view, then that will just cause that data to go down the wire and update in the front end. So that actually should work quite well, because you would literally just have, where do we go? You would just literally have this piece of data getting updated. And I think you'd find that live view will just do the magic to just reflect those changes and actually do it in a very efficient live view way, where it's just the necessary mods, not like re-rendering the whole thing, right? It should just basically do the diff and handle that in place. So that particular library, where are we? Oops, config, oh God, I just can't remember my way around this project anymore. Okay, here we go. There it is there, Plotly X, not on Hex, unfortunately, just a straight up Git URL. But yeah, really easy to work with. And all it's doing is just wrapping the usual HTML and JavaScript suspects that you would have when you're putting a Plotly chart together. Because I actually did spend a fair bit of time searching for charting libraries that might work for this. And I thought, you know what, I'm just going to stick with Plotly. And then I came across the Elixir wrapper for Plotly, and I thought, well, great, because charting libraries and trying to represent visualized data, that's like a whole thing in itself. It's like trying to learn an ORM. You've got to know a lot about the structure of the data and the various configuration parameters as you're trying to put the chart together and display the data. You can really lose a lot of time getting that right.
Absolutely. Yeah, in previous life when I used D3 and learning D3 is almost like learning functional programming as a paradigm, because it has its own way of doing things.
Absolutely. You just put that on your resume on its own, like I'm a D3 programmer.
Cool, that's very cool. I'll definitely check that Plotly X library out. That's really good. Thanks.
Well, and I guess that's like, we'll see how we go time-wise for next month if everyone's interested. If I'm able to get that far and actually get that into a live view and actually have that chart updating live, that's basically the next step for me, is to get it to that point. So once I've got that done, I'll stick an issue in the Elixir Sydney GitHub, and we'll have a go.